Good morning. Let us study today sulfur system. It is a one component system. Normal phase rule is used to describe the phase diagram. F equal to C minus V plus 2. Okay. Let us first study about sulfur. Sulfur. What is sulfur? Sulfur exists in two crystalline forms. We have studied earlier. Sulfur exists in two allotropic forms, sulfur rhombic and sulfur monoclinic. Sulfur rhombic is more stable at room temperature. When sulfur rhombic is heated, let us take sulfur rhombic, it is heated powder, sulfur rhombic powder at 95.6 degrees Celsius and 1 atmospheric pressure. It is converted into sulfur monoclinic. It is converted into sulfur monoclinic. This transformation is reversible. Therefore, this phenomenon is called enantiotrophy. We have already studied what is enantiotrophy, what is monotropy. Monotropy is opposite. If the transformation is not reversible, then it is called monotropy. It occurs only in one direction. Okay. Now, below this temperature, below 95.6 degrees Celsius, sulfur rhombic is stable. It exists in sulfur rhombic. Above this temperature, it exists in sulfur monoclinic crystalline form. Now let us see its melting point. Now it is a solid state. Sulfur rhombic has a different melting point and sulfur monoclinic has got 120 degree at 1 atmospheric pressure, 114 degree Celsius. Now once it melted, it becomes liquid at its melting point. It becomes liquid and the sulfur liquid boils at 444.7 degrees Celsius. Therefore, sulfur exists in 4 forms, whereas water exists in 3 forms. Water exists in ice, vapor, liquid. Whereas here, sulfur exists in 4 phases. Sulfur rhombic, sulfur monoclinic, sulfur liquid, sulfur vapor. Okay. Now there is one important condition that for one component system at any time point there can be only 3 phases. Okay, all the 4 phases cannot exist together. At the same time, 3 phases only exist together for one component system. Okay. Now this is the phase diagram. The phase diagram is shown here. A plot of pressure versus temperature. A plot of pressure versus temperature for sulfur system gives its phase diagram. For example, let us take how it is studied. It is very easy. It is similar to water and carbon dioxide system. If you study water system you have this one, right? Okay, you have sublimation curve of ice and some vaporization curve, fusion curve directly. Here you have sulfur rhombic, therefore sublimation of sulfur rhombic, sublimation of monoclinic. Therefore, you have different phase diagram for sulfur because of the sublimation, 2 sublimation curves. In water, carbon dioxide, there will be 1 sublimation curve. Okay. And there is another one is transition temperature. Transition curve is involved in this, whereas in water system there is no transition curve. What is the difference? What are the differences between water system and the sulfur system? Now, let us take sulfur rhombic in a tube or in a tube, sealed tube, and on heating, now you see sulfur powder, sulfur rhombic powder. On heating, the temperature increases, the vapor pressure, you see the vapor pressure increases. It is converted into sulfur solid is converted into vapor. This is called sublimation. So this is sublimation curve. On increasing the temperature, the vapor pressure increases. See, vapor pressure increases. So the curve, if vapor pressure decreases means the curve will be like this. Vapor pressure increases. At 95.8, see, sulfur rhombic is converted into sulfur monoclinic. Sulfur rhombic is converted into, this is the transition temperature. Okay. And once sulfur monoclinic is formed, then it undergoes sublimation. Sulfur rhombic becomes sulfur monoclinic powder, and there will be more vapors. So the vapor pressure increases. There will be more vapor. Okay, because of heating. Because of heating, more vapor pressure will be there, therefore vapor pressure increases. At this point, this is sulfur monoclinic boiling point. You see, this is sulfur monoclinic boiling point, 120 degrees Celsius. At this point, it becomes liquid. At 120 degrees Celsius, it becomes liquid. Okay, at 1 atmosphere pressure, it becomes a liquid, and the vapor pressure increases. Vapor with increase in temperature. Okay, so this is the transition curve and this is the fusion curve. Now let us explain this phase diagram. Let us now explain AB curve. What is called AB curve? AB curve is called the sublimation curve of sulfur rounding. Okay, it gives the effect of temperature on the vapor pressure. It gives the effect of temperature on the vapor pressure. Increasing temperature will increase the vapor pressure. Okay. So next, what is along the curve? There are two phases. Sulfur rounding and vapor are in equilibrium. Okay, I have not given here. You can write along this phase sulfur rounding and sulfur vapor. Okay, are in equilibrium. Therefore, it is monovariate by applying the phase rule. Now at B is called the transition temperature and also called the triple point. When two curves meet, see, when two curves, B is a triple point because when two or three curves meet, the point is called a triple point. At this triple point, sulfur monoclinic, sulfur rounding and sulfur vapor, three phases coexist at the same time, not four phases. By applying the phase rule, F equal to C minus P plus 1 minus 3, it is equal to 0, therefore it is invariant system. Similarly, next AB curve, next BC curve. BC curve is also sublimation curve again. It is sulfur monoclinic converted, sulfur rounding is converted monoclinic, then the sublimation of sulfur monoclinic takes place. Sublimation curve of monoclinic. Along the curve, sulfur monoclinic and sulfur vapor. Here sulfur rounding, sulfur vapor, sulfur monoclinic and vapor are in equilibrium. Okay, therefore the curve is monovariate. Next is B, point C. Point C is another triple point. At this point, sulfur monoclinic, sulfur liquid. This is the melting point. Therefore, sulfur liquid will be there. Sulfur vapor also will be there. Okay. So F equal to 0. Next is CD curve. CD curve is the vaporization curve of sulfur monoclinic. Sulfur liquid. At this point, sulfur melts to give liquid. Therefore, this is the vaporization curve of sulfur liquid to sulfur vapor. Okay. Next, you see BE, this curve. BE curve is called transition curve. BE curve is called transition curve. Along the curve, sulfur rounding is converted into sulfur monoclinic. Along the curve. This curve also gives the effect of pressure on the transition temperature of sulfur rounding to sulfur monoclinic. Effect of temperature. For example, at this pressure, at 1 atmosphere pressure, 95.8. Suppose this pressure, transition temperature increases. At this pressure, transition temperature increases. Therefore, the effect of pressure on the transition temperature, this curve gives the effect of pressure on the transition temperature of sulfur rounding to sulfur monoclinic. Because of this is tilted away from y-axis. Suppose if it is tilted this way, in the case of water it will be tilted. Therefore, increase in pressure decreases the transition temperature. Here this way. Therefore, increase in pressure increases the transition temperature. It may be asked. This is because we have studied volume of sulfur monoclinic is greater than volume of rounding. If it is opposite, then the curve will be like this. For example, in the case of water, volume of ice is greater than liquid. Volume of ice is therefore this side. Okay. Next, in the case of carbon dioxide, this way. Okay. So CE curve is called the fusion curve. Fusion curve of sulfur monoclinic. Along the curve, there are two phases: sulfur monoclinic and sulfur liquid. Sulfur monoclinic and fusion. Fusion means melting curve. CE, fusion curve or melting curve of sulfur monoclinic. It is melted into its liquid, sulfur liquid. Okay, this curve gives the effect of, similarly, this curve is also slanting away from the y-axis, and not this side. It is slanting. This curve is slanting away from the y-axis, pressure axis. Therefore, increase in pressure increase in pressure. For example, this is the melting point or fusion point, melting point or fusion point. With increase in pressure, it increases. With increase in pressure, it increases. Okay. And next, we have come here. See E. What is E? E is the third triple point. E is the third triple point. And this triple point, what are the phases coexisting? Sulfur rhombic, sulfur monoclinic, and sulfur liquid. Sulfur liquid is the sulfur monoclinic and sulfur monoclinic. Okay. Therefore, now the next one is the daughter lines. See, these are all the metastable equilibria. Daughter lines, the daughter line curves correspond to metastable equilibria. There are three metastable equilibria. There are three curves: BA dash, CA dash, EA dash. Okay, along BA dash, sulfur rhombic. This is along the sulfur rhombic. This is sulfur rhombic. Up to this sulfur rhombic is in equilibrium with the sulfur vapor. Sulfur rhombic. Similarly, CA prime, sulfur monocline, sulfur liquid in sulfur. This is the liquid in equilibrium with the sulfur vapor. EA prime, sulfur rhombic. EA prime, sulfur rhombic is in equilibrium with the sulfur liquid. There are three metastable equilibrium. How this curve is explained? See, please listen. Now, on sudden heating, sulfur rhombic to 95.6 degree. Sulfur rhombic is not completely converted into sulfur monocline. See, you are heating suddenly, all of a sudden, it is heated to 95.6 degree. Therefore, see, sulfur rhombic, when sulfur rhombic is converted into sulfur monoclinic, there are change in molecular arrangement. There are change in atomic arrangement because this is a rhombic unit cell. This is monoclinic unit cell. Therefore, there are rearrangement of atoms. If it is slowly carried out, see, this is for slowly carrying, for slowly heating. You need to heat slowly. Then it will follow this curve. If you don't heat slowly, then all of a sudden you are heating sulfur rhombic. Here in this curve, all the sulfur rhombic is converted into sulfur monoclinic along this curve. Whereas here, this is sudden heating, or this curve is sudden cooling. This curve is due to sudden cooling. Okay, of sudden cooling of vapor to liquid, this is a super cooled liquid. Okay, thank you for watching.